Today, we have Remco and Bas, and as they're friends of mine, instead of just editing, I am also hosting the podcast for the first time. The audio quality isn't the best, as we're all taping from different locations, but hopefully you can enjoy the content. Mun is a dynamic scripting and embeddable programming language written in Rust. Its core features include hot reloading, static typing, and it's really fast, which I know will appeal to a lot of Rustaceans out there. The authors hope it will someday be the natural successor to the scripting language Lua, which is very popular in the game creation space. Today, we're joined by Bas and Remco, my friends. Guys, welcome.
Hey, thanks.
So I want to know who you are, so let's start with you, Bas. Who are you?
Well, I'm Bas, and I'm from the Netherlands. I used to work at a company called Abbey Games for, quite a long time, as one of the founders, actually. And we did a lot of Lua programming there, and at some point, I actually left the company for a bunch of reasons, but I still wanted to keep going with, game programming
We'll
languages.
have to put a pin in the Lua thing, because I know it's pretty essential to some of the reasons and some of the philosophies and whatnot behind the Mun project. Remco, who are you?
So I am also from the Netherlands. That's where I actually met Bas. We worked together at Abbey Games. He hired me there, and I worked there for a year.
Long tenure then.
Yeah, that's when I went to Japan, where I met you and actually hired you. So see all the connections here.
Yeah, so much.
I am currently engine programmer at Ubisoft, and I've worked in mostly the VR and games industries.
Cool. So the Lua thing that Bas just mentioned, that's got a lot to do with Mun. What is Mun?
So Mun is a programming language that's fully focused on providing quick iteration times, and the main feature we use there for that is hot reloading. So anything in the language can be hot reloaded at runtime, which is not a unique feature, but it is in combination with static typing and compilation to machine code. So it's also very fast.
Hot reloading versus Rust, which is a compiled language. That might be a bit of an unusual concept to meld for some of our audience, because they might be thinking that compiled languages don't hot reload, because every time you want to do something, you recompile them, for example. So how does Mun look in that space?
So I think they don't per se, I think they could go together well. In a sense, what, for example, Unreal Engine is doing is they're C++, so it's a compiled language. But if you use shared libraries where you compile into a shared library, you can hot reload all of those shared libraries. So that's an approach that has been around for a while. But we felt that it was limiting in the sense that you need to have a predefined header with that particular library, and the header contains all of the function definitions that you might want to use, and then you can hot reload those functions. But then it's limited to just those functions. Then there's also Live++, which Unreal Engine later adopted, which applies patching of executables. So they're actually able to patch an executable with new code that's there. But you still have the issue that you're limited mostly to functionality and not hot reloading of actual data, which is where we felt that we could improve on the current use cases. And this is also something that Bas, he can attest to this. At Abbey Games, he did a lot of hot reloading of data as well, and he had some design paradigms that they introduced that worked well with it. But we actually designed the language to, from the core, support this. So we are aware of what the different types are, what the layouts are in memory, and transitions in those memory layouts, we can actually adapt at runtime and make sure that your memory gets mapped so you can keep using the memory that you previously had without ever having to turn off your application.
Does the reuse of... Sorry to interrupt you there, but the reuse of memory thing, obviously Rust doesn't like it when you try to access memory that you're not otherwise supposed to be accessing, right? Is that something that you've had to fight with or leverage in the creation of Mun?
So we are big fans of Rust because of the guarantees it provides there. And in theory, it does allow it, but we did have, in this case, needed to introduce some unsafe code because we are using some data type, which all of a sudden is unloaded because we're still using shared libraries, but we're loading a new version of that same data type, which might have changed. So we had to like create a safe wrapper around it where we have to provide some guarantees about when you can actually swap out these data types such that it's actually safe in usage.
Yeah, definitely. I feel like we should probably address the why is hot reloading so important, specifically in the game development space, for example.
Well, hot reloading is very important because specifically not just in the game development space, but game development space, one that uses it a lot, is it's all about iteration. You want to implement a specific rule, test it out in your game, and then find out whether it works or not and modify it. At the same time, you also don't want to shut your game down, have to implement something, then restart your game, because that takes a lot of time. So with our approach, you can simply create game rules or whatever, really, implement it again, and see it immediately on a second monitor, for instance. This is the approach that we took at Abbey Games, and it was very successful because we were able to very quickly iterate on new features that we implemented.
Is this sort of optimization for engineering time something that you think will make MUN very successful?
Well, I don't think it's MUN specific. Like in the web industry, this has been done for a long time. So change something and the page refreshes and you can immediately see the result.
Sure, but the data being marshaled around in a web use case versus the data amounts being marshaled around in a game use case, for example, and even the hardware that they're executed on, or etc. It seems like they're worlds apart. It seems very possible that someone could be doing something like this in like just-in-time compiled languages like JavaScript or something like that. But if I'm picturing like a AAA game title that the kids are playing or whatever these days, it's hard to imagine that being hot reloaded. Is MUN a step in the direction towards having hot reloading for that sort of thing, where you've got really heavy 3D assets, billions of polygons or something on screen that are pushing gigabytes and gigabytes worth of data back and forward to a GPU or something?
Yeah, so
like that?
I think it's a big step forward, but I think so languages like Lua were able to do this, and we are an incremental step on what Lua can do by also having static typing. So that means a lot less runtime errors. And the other addition that we have in terms of Lua is that we are compiled ahead of time, so there's a performance gain. So I'd see us more as an incremental improvement over Lua in those two aspects, and then maybe with the integration of both our compiler and our runtime, we can experiment with some new features that weren't possible in Lua, such as the memory mapping, and that might provide some significant like developer experience improvements that weren't possible in the past. But I think that this is still very much a journey of exploration where we are trying to figure out what are good paradigms, what are good high-level designs that we can use that can actually boost this productivity. So it's hard to say for sure now this is going to be this big of a change, and it's going to be 50% more efficient or something. This is still exploration.
Yep. For anybody who hasn't seen, they should definitely check out the video that you, Remco, posted in the Rust Reddit around the competition that we'll talk about a bit later, that was showing you implementing Pong, because that's pretty fantastic to just see you creating new structs and things like that on the fly, and creating new behavior and things like that on the fly. And on the other side of the screen, the game that you are creating is being born, within nanoseconds of you typing it out into your editor, which is pretty fantastic and cool. And also it's a very different experience to what most people will have with Rust, where they spend ages writing something out and then they compile it, and maybe if it's a big enough project they go and make a coffee or something like that while it's compiling, and then they come back and see the fruits of their labor. Whereas obviously MUN is going to help, well, at least people in the game space in the short term, and hopefully in other spaces in the longer term, potentially get past that and spend even more time in front of their screen. Yay.
Precisely. Yeah, let's hope so. And I think with that, we're also tackling a big issue that was mentioned in the Rust Game Dev Working Group survey. Last year they did a survey, and earlier this year they published the results, and one of the issues that came forward was the compilation times of Rust. And especially with things like this, Rust is an awesome language, but one caveat is that compilation times tend to be a bit long. So if you can alleviate this with an embeddable programming language, like Mun, that would be great. You have the best of both
So
worlds.
you just mentioned embeddable programming language there. That will be a familiar concept to many, but it's definitely an unfamiliar concept to many. And as in the spirit of trying to be as accessible to as many levels of Rust programmer
So,
as possible, what is an embedded programming language? Sorry, like Lua,
yeah.
for example.
So from a lot of languages that you might be familiar with, you write your piece of code and that generates some command line interface which you can just run. It's an executable. Um, with an embeddable language, this is inherently not the case. You don't have an executable, but you generate some form of library with functions that you can call from another application, which we call the host application. So you would have bindings in that particular language, and then you can call the functions and you can marshal the data into your host application and use this as like a pairing of two languages.
Cool. That's a good definition. Do you want to add anything to that one, Bas?
No, not really. Well, maybe a language doesn't have to be either embeddable or not embeddable. Some languages can do both, like C#. As in, you can embed your C# application within your own application, or JavaScript.
So,
yeah.
Who's going to use this? Obviously, game developers. Any in specific?
Any in specific? Ooh. Not that I know of currently.
So the only ones that we know of at the moment, Valoran, which is a Rust open world voxel game which is being developed, they're experimenting with Mun for some systems. So recently they implemented their animation system using Mun because they were still working with a lot of config files. And even though Mun is still in the early stages, it does offer some advantages in the sense of actually being able to program logic as well as configuration on the fly. And they've also looked at Mun for modding. They're very interested in using a modding system so people can just add their own content to Valoran. But this is still a long-term project, so they've just investigated and done some experimentation. And we've actually also posted a GIF of them integrating Mun in the past on our blogs. And apart from that, there is no, like, there's just indie people, contributors who are just trying out things. And that's why we also started the contest, Make It or Break It with Mun, in the hopes that more people would start making interesting creations with the current iteration of Mun, so we could actually get some feedback on how we can improve, because we are very adamant on getting feedback from our community and choosing our roadmap based on what we as a community as a whole want to achieve.
Yep, give the people what they want.
Precisely.
Okay. In terms of what's on the roadmap, what's the next thing you think that is the most likely contender that everybody's going to tell you they want, that you're already probably halfway through implementing?
Well, we develop using a TikTok model. So we do a tick first, where we implement a lot of features, and then we do a talk, which is then the next release, where we try to improve the ergonomics and fix all the things that broke by accident. We are currently in the talk phase, where we're iterating on our latest version 0.2. But yeah, probably the biggest feature that's missing still is arrays. So currently we don't have any arrays, and while we try to create simple games, you ran into that problem quite quickly. Where and for instance with Pong, if you need one or two balls, an array would already be very nice. So yeah.
Yeah. Okay. You mentioned at the very top that occasionally some things to do with decisions made about the way that the Rust memory model was going to work have been difficult for you, and as a result of which you'd have to create a as safe as can be wrapper around some unsafe code, specifically in the area of memory allocation thing. Is the lack of arrays right now a symptom of that particular issue by chance?
Well, yes and no, I think, because one of the things that we steal from Rust in this language is that everything has to be initialized at all times. And for arrays, that's especially dynamically sized arrays, that's been a problem for us, because we're not able to create an array type within Mun itself, or dynamically sized array type within Mun itself. So yeah, we're investigating how we can integrate like the array type in the compiler itself, and also make it dynamic. And that's been
Interesting.
interesting. Yeah,
Yeah,
that's a
yeah,
good word.
yeah. I
Yeah.
can imagine it's you're somewhat thinking there's probably many ways to do this that might be really slow, and speed is the name of the game. So why would we want it to be slow, right?
Yeah, and especially because we want to enable hot reloading for everything we implement. So we also need to support hot reloading of those arrays.
That's a very conscious decision that we made in terms of workflow. We only want to add something to the language once it's hot reloadable, because we could just be adding a ton of language features really quickly, but they'd not be hot reloadable. And since that's our big design philosophy, we feel that that would not be the correct way to go about it. So there's just a lot of design decisions that go into coming up with something which is
Good.
both ergonomically good and also performant and hot reloadable. So
Yep. When you're this emphasis on hot reloadable, can you talk a bit about how did you make something like this? Because demanding that every single thing that the programmer wants is hot
it
reloadable
sure is.
sounds hard, especially in Rust. It not only sounds hard, but is it unreasonable to expect this? Is it unreasonable to expect that everything you create as a programmer is hot reloadable? Especially in a gaming environment where, as we sort of alluded to earlier, sometimes stuff is big and ugly and complex in a game.
So even with structs, which is in terms of like all the possible things you could do in a programming language, still fairly straightforward, there were certain things where it might be impossible to determine for us whether something is hot reloadable. So with the struct memory mapping, there are some corner cases where you cannot determine what the intent of the user is, because the user is writing code, and based on what you get in the compiler, which you process as text, you're going to try and determine, okay, these fields changed in the struct, but which one maps to which one? And sometimes there are multiple correct answers to that, and then there's no way to find the actual correct answer, so we try to find the best possible answer.
How do you decide what a best possible answer is?
So for us, the thing that guided that design decision was it's better to retain information than to lose it, because once you lose it, you can't get it back. So when designing the struct memory mapping, we always chose to err on the side of safety and make a conservative decision to retain memory. So for example, if you'd add a field and you'd remove a field, but the types of those two fields are the same, then we're saying, okay, you probably renamed this field. So it retains the data of the old field, but you just have a new name for the variable. Maybe you actually deleted the previous field, added a new one with the same type, and you wanted it to be reset to a default value. The other way around, you would have lost your data if you actually tried to rename the field, right? So that's worse. The ergonomic downside of this is if you actually want to delete a field and add it, you just do it as two steps. So you delete the field, you save the file, and then you add the new field, and then you're at the same stage, basically. To answer your overall question, I think it is not, it has been done before, in the sense that a language like Erlang, which is its goal, I think, is to try and stay online always. So it's used in phone transmission, like if
Telecommunications.
The way telecommunication. Thank you. Yeah. So the way they go about it is they allow for things to fail, but the overall structure always stays on, and they have certain design decisions where there can be different versions of the same executable running at the same time in different asynchronous threads. And that is something which also serves for us as inspiration, like, okay, we can't potentially use all the things that you're used to in Rust or other languages, but are there things that we can take as inspiration from languages like Erlang that we can use to design our language? And if it's been done before, it should be doable again, right?
Well said.
I think another thing to add here is that you can introduce faults in your program by hot reloading. So for instance, take a hash map. If you have a hash map of some value t, if you change the hash functionality, your hash map is then in an inconsistent state because you cannot compute the hash in the same way again. So that we also have to look at ways to know when your when an element, for instance, or a specific type has changed within the language itself. And
Do you?
that's hard.
Yeah, definitely. Yeah, by definition, like if you hash something at a certain time, it's not going to be the same the next time you hash it in a different way. So that makes perfect sense. Do you think there's some things within Rust that you can specifically leverage for this? For example, I mean, somebody more versed in Rust will say it more eloquently than I, but you by default, Rust variables, for example, are immutable, right? So you declare them mutable, blah, 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 and then you can take pointers or mutable pointers and all of that sort of thing to things. So there are mechanisms within Rust already whereby which you should be able to take something out of memory and just relabel it, or, move pointers around, if you will, in the sort of way that Rust tries to encourage you not to do. But is that the sort of thing that you're looking at when you design something like Mun, and you think, I want these, like Remco was saying earlier, I have these structs and these structs have these fields, and probably I've just renamed one, so actually I shouldn't drop the whole thing. I should probably just take this new name and adjust my pointers as so.
I don't know if there's stuff in Rust itself that we can use to leverage that, but yeah, we see that there are two kinds of hot reloadability. You have the memory mapping type kind of hot reloadability, where you just replace implementation and memory with something else, and then you have the higher level concepts like the one with the hash map. But there's also there are also other ways to structure your program to make it easier to hot reload. For instance, reactive programming is an example of that, where it's because you're able to rerun your code and get the same result. That's also a form of hot reloadability.
Why did you do this in Rust? There's so many languages out there. Obviously, Rust is very cool. Obviously, this podcast is pretty biased towards the coolness of Rust. But why did you choose Rust for this project?
Yeah, good question, really. Well, I think mostly because we really like Rust, and it forces us to think about the design of our programs as you're programming it. It has a great testing framework, which we use a lot. And generally, it's just a great language to work with.
Yeah. I think for me, like coming into this project, Bas and I had very different goals, and we still are not, in general, we are aligned in the same direction, but we're coming from two different perspectives. So I was programming a lot more in Rust at the time, but there was this one caveat which was just itching me, and that was the compile times and hot reloadability. So for me, this started out with actually experimenting in Rust and how can I get hot reloading in Rust itself. And the previously described method that Unreal Engine uses with shared libraries, which you can just plug and play with. People had already done that in Rust, so I started experimenting with that. But then I quickly ran into the boundaries of, okay, I can do functionality, but how can I actually get this to work with structs, etc. For me, because I was working with Rust, I'd gotten familiar with it, and before that I used C++, and I could just all of the benefits that I get with Rust development, I feel like I'm much more productive. With C++, I feel like you are very good at C++ if you're very good at debugging, in a sense that no matter how much you think about a design, inevitably some mistake will slip in with either memory management or threading, and you're going to have to debug your issue at runtime. With Rust, this has been much less the case. The number of times that I have to debug probably relate to me using unsafe code, which is just equivalent to writing C++ basically. So in that sense, there are a lot of mistakes I make, but the compiler tells me, okay, you're doing this wrong, this lifetime is incorrect, and then it forces me to write better code, I feel. That code that's better structured, that's better architected in general. Often even it makes it more data-driven, which is more aligned with how the hardware of computers actually work. But this is just my feeling. This might not actually be the case. And then the ecosystem is great, I feel, as well. There's a lot of crates that even now we're benefiting from. So there was this, I might mispronounce the name, but there was this great article by Matsakis. He's one of the Rust core team members. And he was talking about librarification of the Rust Nico, yeah. He was talking about the librarification of the Rust compiler, where they're splitting off these parts, they're splitting off the part that's doing all of the parsing. So now we have Rust Analyzer, and they're trying to see if they can share a lot of the code base. And then the same thing with traits and determining like which traits are correct to use, etc. They also have a separate crate for that. And that opens the door to languages like Mun and other potential like domain-specific languages to benefit from this ecosystem. So there's this great crate by Matklad, the maker of Rust Analyzer, Salsa, which we're using as well, which allows us to do a lot of or we can basically skip the groundwork for incremental compilation for Mun by leveraging these crates. So like that's the second big point for me. And the third one is the community. Like the community is very supportive, very open, and in a sense it differs. Yeah, precisely, right? Yeah. Yeah, and one good example recently, like the post that you referenced about the Pong game, I posted that on both or like several subreddits, the Rust one, Game Dev one, Rust Game Dev, and then someone on Game Dev mentioned like, oh, you guys also have great bindings for C++. Maybe post it there too. So I adapted the post, only referred to things that said C or C++ because I was a bit hesitant about mentioning Rust there. And then the first question I got was Rust. And it's like, well, it's written in Rust. We have like very good support in Rust, but we also have great bindings, to which the person who had requested the post mentioned as well. And it was removed. It was censored from C++. So that just shows a little bit of a difference of how the communities work.
That thing you said about the community is, yeah, I mean, when Remco and I first met, I'd never programmed anything in my life, right? And I'd just bought a book by Al Swaggart called How to Automate the Boring Stuff with Python. And Remco was like, oh yeah, cool, have fun. And it was nice of you. Thank you for not, raining on my parade when I said Python in front of you, even though you were writing a lot of C++ at the time, because many others did, right? But the Python community was really kick-ass, and I can say the exact same thing about the Rust community. Like when I decided I wanted to get a little more serious than Python, I wanted something a little more performant, for example. I'm not raining on Python. Python's fine. I love Python. I just happen to have come over to Rust, and I think I like it more. But the Rust community is definitely taking a page out of the Python book in that if you ask for help in the Rust community, you get a million people giving you the best advice. And they're also friendly, and they're also nice. But if you ask for anything on the C# or the C++ forum, sorry, it's just it's not a nice place to be for a beginner, maybe even for an expert.
And just to say, like C++ has a right of existence. There's a lot of code in it already written, which only attests to like what it's capable of, and there's many different programming languages which serve different purposes, and they can coexist fine. It's good to just keep an open mind. Okay, like what language is best for the context which I'm working in now, and Rust often makes a lot of sense. And hopefully in the future, Mun will make even more sense for the target audience that we're aiming for.
On the idea of Mun being its sort of own, it's its own programming language in and of itself. Anybody who, I'm looking at some Mun code right now on your website, for example, and it looks like Rust. Is this a byproduct of it being made in Rust, or is it an intention, or do you want people who are fluent in Rust to automatically be able to pick up Mun, or vice versa?
I think Rust made a lot of great decisions, and when we come up to something like we have to make a similar decision, we're quite biased to go the Rust way. That's one of the things. There are also other languages that we steal things from, like our syntax used to be a little bit closer to TypeScript, but then a lot of Rust people came along and they said, this is weird to me, and we were like, okay, whatever, we'll change it. So that also influenced the syntax quite a bit. I don't know how close we're gonna stay to Rust. There are also subtle difference. There are already subtle differences, and I think that in the future there will be more because we want to integrate these high-level hot reloading concepts that might introduce new constructs altogether. But yeah, so far we're trying to stay close.
What are some examples of these subtle differences that are, I mean, at least syntactically or grammatically? I guess. What do you say? Grammatically, syntactically,
Well,
syntactically.
Currently, a struct in MUN can have two memory models, so it can either be a garbage collected struct or it can be a value struct, which is basically a stack allocated struct. The difference is they're allocated in either the stack or with the garbage collector, and the way we pass them around. So a value struct is passed around by value, and the GC struct is passed around by reference. And we annotate that different from Rust, where you would create a new type like GC and then struct type. We annotate this at the struct level itself. So you say struct and then parentheses open value or GC. That's a small difference.
On the topic of garbage collection, what was the inspiration for the garbage collector that you've created? I mean, there's a few runtimes popping up now for Rust that are doing things like this. Did you draw inspiration from Tokyo or from, I don't know, from the garbage collector in Python? Like, where did it come from?
Well, our current garbage collector is, crap. Because it's
garbage. You should have said garbage.
Ah, shit. But it's not great. But that was not the intent. The intent was to have a garbage collector and in the future focus on or let other people work on implementing a much better garbage collector. And we already see this happening. There's quite a large number of people in our community on Discord that are looking at ways to do better garbage collector, and not just for MUN but for Rust in general. So that's very interesting to see.
We're big believers in co-development, so we try to look for avenues where we can contribute back to the Rust ecosystem. So when we made the GC, we knew it takes a lot of time to make a very good garbage collector. Go has a very good one at this point. C# I think also does, but it took them a lot of time to get to this point. So we thought, if we want to invest time in that, we can't focus on other aspects of the language. So let's set it up into a trait which we can just expose, and anyone can make a MUN garbage collector. And obviously the first pass wasn't perfect for this trait, so people commented on this and then we tried to improve. But ideally, we'd get all of these garbage collection crates which can be used for MUN, but then also for other projects. So if someone makes their game engine and they want to use a garbage collector in Rust, then they can do that because that crate just exists at that point.
Hear that, viewers, listeners? Any of you could make a garbage collector. Specifically for MUN or just for Rust if you wanted to. Maybe it would be a very interesting actual project for someone, because probably if you were going to be implementing a garbage collector for Rust, whereas if you were going to be implementing a garbage collector for C#, for example, well, C# isn't as strict as anybody who knows any. If you've written any C#, you'll know that they're not as strict about memory management as Rust is, and maybe that stringency is something that an implementer could work with. If the lifetimes are all specified, for example, then well, garbage collection should be easier, right?
Yeah, I don't remember the name, but we've seen a few crates actually that implement the garbage collector for Rust and also use the lifetimes to make it easier and I guess faster. So it's very interesting to see.
Anyway, we'll move on from garbage collection because, like you said, you want someone else to do it.
But there's also another language, GameLisp, which has a very interesting approach about garbage collection, because their approach is not to create a general purpose garbage collector, but one that if you acknowledge that you have frames that you like in a game, you want to spend time in a frame to do garbage collection, but you want to do it with the same amount of time every frame so that it doesn't have a big impact. That's also an interesting approach to garbage collection, because if you can just minimize the spikes,
Yeah, the
that's
concept of
also
frames for anybody who hasn't done any game dev might be a little unusual, perhaps. So maybe it's worth somewhat explaining that for most games that you play on a screen, it runs at some sort of refresh rate. Usually your screen or your OS gives you like a clock, for example. If you're on like a 144 hertz monitor, then that's going to show you 144 images per second, which is roughly one image every 6 milliseconds. So the idea of a frame, as you were just saying it, Baz, is that the Lisp game garbage collector, if it's working on this 6 millisecond frame time, then it's dumping everything every 6 frames because it knows it won't be used again.
Well, it just tries to spend a maximum amount of time per frame, and then it won't get it away.
Yeah. Okay. So if it gets to the maximum time per frame, it just moves on to the next work.
It's interesting that Bas mentioned Gameless, because we are seeing a trend, and we talk a lot with Erland, who is one of the directors at Amethyst Foundation, and he is also seeing this trend that there's a lot of people making scripting languages or other using Rust. It seems that Rust is becoming a very popular platform to make these languages with. And we are just one example of that, and Gameless was another one.
Why the trend in new gaming scripting languages?
I think something like LLVM, which Rust is built on, is one big component of this. You can just compile whatever syntax you have to, or transpile to LLVM IR, which is the intermediate representation that LLVM has. And then you can just compile it to either a machine code, or I think LLVM also has bytecode support for interpreted languages, if I'm not mistaken.
Very cool. Very cool. How do you guys want to build a community for Mun?
Yeah, so the reason why I put that in there is because it's something that is very big on our list. We always knew, like, going into this, we are making a language which is emphasizing that, like, we want iteration times, right? Iteration times mean it's for creators. If you want to build something for creators, you need to know what creators actually want, because we are just two people, two perspectives, and what do we really know in the end, right? It's only a small subset of what everyone knows. So the only way to get to know more is through community interaction. So from the get-go, we were focused on, okay, let's build a community together. Let's give everyone a voice. We do that through Discord, where people can come and talk. So as Bas mentioned, lately we've seen a lot of talk about garbage collectors because we raised that topic, and then it hit something that a lot of people care about. So we have a lot of interaction. There's people from scientific institutions, universities. There's people who are just writing their own toy languages with a GC. So there's a lot of different perspectives that you get there. A lot of knowledge is there that's being shared. So that's very interesting. And then people can reach out to us, obviously, on Twitter. We post often on Reddit, where people can have their discussions. That mainly it happens within the Rust subreddit at the moment, where people seem to be very engaged with the idea.
I'll put links to Remco's Discord and the Mun Discord and the Mun Twitter and the Mun website and all of that in the show notes for everyone to take a look at. As you're building this community, you said you were looking for feedback from creators, because creators are going to be using it, and the people using the tools are going to give you the most accurate ideas about where and what you should focus your effort and time on. In terms of people who want to get involved with Mun, perhaps on a deeper level than just using it, if someone was to contribute, how does that work? Are you guys accepting pull requests, etc., etc.?
Yeah, of course. Like the same thing applies. 2 people can only make so much, and the more people contribute, the better. So we have good first issues, which are entry-level issues where people can get familiar with our workflow, and they can start getting familiar with the code, and then contribute something and incrementally increase the size or the scope of whatever they're doing. Then the other thing that we did was the make it or break it contest. It was very conscious. On the one hand, we want people to use Mun and give us feedback, but it might be only targeting a very specific audience, people who are creators, and other people might not have that creativity in terms of making a game or an application, but they'd rather be on the side of like bug bounties, stuff like that, where they actually want to figure out how they can break something, introduce a bug that we can then fix, which is also very valuable to us. So we've seen a lot of interesting bugs as well these past 2 weeks, which we probably wouldn't have come up with ourselves. So that's very good.
Oh, okay. Is there any particularly notable bugs that were squashed that you feel are worth mentioning?
Well, the one I've been working on the last couple of days is we're using LLVM, and I just use the release binaries from LLVM. But if you compile LLVM with assertions on, there are a lot of assertions that are triggered by our code. So yeah, I've been quite busy fixing that.
And I think my most favorite so far was one where someone created a temporary, which basically is you create a struct at some point, and then what they did is they instantly requested a value of that struct and then returned that. But I would have never come up with that.
What's been your philosophy while you've been trying to implement Mun to keep it usable, other than copying everything that you think is good about Rust?
Well, yeah, I mean, one of the issues I had with Rust when I started out was there was no IDE integration at all when I started, and that was really hard for me to get into the language. And once I started using Sea Lion, for instance, I started using Rust also a lot more because of that, because of the great integration it has. And the same thing applies to Mun, I think. Especially now, we need a lot of people to get involved into the language. So we need to make it as easy as possible for people to pick it up and start using it, as well as start integrating it into their own projects. That's why we also want to focus on, for instance, a language server to integrate Mun better with an IDE and Visual Studio Code, and in this case. Yeah, simply because if your IDE helps you to learn the language, it just makes it easier to learn.
Yeah, absolutely. And Remco made mention earlier, I think you mentioned Salsa, which is obviously made by the same fellow who made Rust Analyzer. And for anybody who is out there trying to learn Rust, get Rust Analyzer. I'm quoting Remco here, actually. Like the last time Remco was visiting me in Tokyo, he said to me, "Jeremy, get Rust Analyzer." Are you still using Rust language? I can't remember what the previous one was even called now. I'm sorry. Sorry to all of the developers who have spent so much time working on the Rust language server protocol. Yeah, Remco said to me, like, get Rust Analyzer. He said, it'll make your code look really weird because it's going to put all this stuff in your editor that you didn't type, but you need it. And he was totally right. Totally right. Anybody who's not using Rust Analyzer, get it.
Yeah, or C Line, because I'm not using Rust Analyzer. I'm using the C Line integration.
Oh, okay. So the last time I saw you, Remco, you had C Line open on your machine, but the Pong video I saw the other day was definitely VS Code. So what's going on, man? Have you come over to the Electron dark side?
So like you can't really attest to how good something is if you haven't tried the alternatives, right? So so Bas was a very like predominant C line user, so I tried it. But then part of me, I'm a big believer in open source software and having things freely accessible for people so they can improve and they can learn. So that's why I feel like dogfooding Rust Analyzer, use it, and if there's issues, report them and help it get better so everyone in the world can benefit from that. But then said JetBrains, who are the makers of Sea Lion, also have great opportunities for people to try out their tools for free. So like they're also doing great work. So nothing bad about them.
Yep. Just to be clear, the podcast has no particularly favorite IDE. We're not advocating for one over the other. Recently, I've been making the move to Vim, which has Rust Analyzer. But there's many ways you could have your Rust Analyzer turned on in Vim. You could use Coq, or you could use or you could just use the Vim LSP integration, or you could use uCompleteMe. There's a myriad of things. I encourage all beginners and all experienced programmers to go out and find the editor that's working for them. And then, as Remco said, even if it's working for you, try something else. We should really mention that the Mun project is made possible by some sponsors and some grants. So do you guys probably want to say thank you to a couple of big names. Some of them are pretty
definitely.
predominant in the Rust space, you know?
Yeah, like Mozilla being like the instigator for Rust altogether. They're doing great work in general within the community. But one thing that they're also doing is they have the Mozilla Open Source Support Grant, which helps out open source project in 3 different tracks. And we were a mission partner, so we align with their mission and we're trying to further that mission. And in our case, that is empowering creators through a quick iteration. So we got a grant from them, which we were very fortunate with. And the collaboration throughout that grant, we had set certain goals, and like the end product basically became MUN version 0.2. So struct hot reloading. And like the entire process was very rewarding. We got good feedback, made good connections, had a lot of support. So that's very good. So if there's people working on open source projects which they think are also a potential candidate which are contributing to the community, have a look at it. Maybe it's something that's interesting for you that can help further your development. Then another big one is the Amethyst Foundation. Erland, I already mentioned. He's been advising us, and then also the Amethyst Foundation became our fiscal sponsor, which allows us to, like, as a small group, not have to deal with all of the paperwork. And we can still receive donations from people who think that what we're doing is worthwhile and who want to help us further that cause.
Beautiful. What's the best way for people to contribute if they're not able to give their time in, say, the Make It or Break It contest, or if they're not able to file a pull request because, you know, maybe they got other stuff on? How do people help out? How do people contribute? How do people give you money? So
we have a GitHub sponsors recently added. So you can donate there, or we have an open collective, opencollective.com/mun, where you can also donate. And like, we're happy with anything. Part of it contributes to us being able to work on this. Bas works on this 1 day a week, so he works 1 day less, and then I also work on it. So like the ideal would be that we could probably work on this a lot more than we do now, but unfortunately reality is that money is needed for that. So we've been looking at other ways to monetize instead of grants and donations, but it's quite tricky, especially for a language.
Yeah. Well, I think we know the answers to my last 2 questions, which I'm stealing from a very popular Python podcast, actually, by Michael Kennedy. He always asks people at the end, he says, you know, so if you're going to open up your computer and you're going to write some Rust, what editor do you use? Let's go, Bas.
What editor? For me, it's C-Lion, definitely.
C-Lion, definitely. Yeah. That's a powerful adverb there, definitely. Yeah. Okay.
I tried Visual Studio Code as well, but no, it's definitely C-Lion for me.
Okay. What about you, Remco?
Yeah, VS Code.
Yeah. Okay. And both of you have got to shout out a particular crate that your favorite crate is.
Mine is definitely Rust Analyzer. I mean, if you look through the source,
is that a crate?
Well, it's a collection of crates, yeah. But if you look through the MUN source code and then you put the Rust Analyzer source code to the side, then there's quite some similarities in the way we approach things.
Okay. Yeah.
It's a big inspiration.
What about you, Remco?
I think I'll go with Criterion, which is an interesting choice.
Yeah, okay, that's Brooke Helsler's crate. He's the author of Rustacuda.
Yeah. Well, the reason is why, like, there's a couple of things which are very important. One is unit testing, but it's already an integration testing, etc., which is already possible with Rust vanilla. But then another big part for us is benchmarking, and Criterion is really good for benchmarking. So, what sort of things is MUN benchmarking, and why? And do you have some very clearly defined metrics for what good performance is for you? The biggest impact that we're taking in terms of performance is when you're marshalling between the host language and the embedded language, in this case, MUN. So the things that we're benchmarking at the moment are when you're invoking functions from that host language, or when you're marshalling data. And then we're comparing that against Rust native, if you wouldn't have to invoke anything. Or WASM, which is also a big option for at least like modding or sandboxing. and the other one is Luajit, which is basically our hopefully predecessor in the future. And if we're doing better than those last two at least, then like we're heading in the wrong direction in terms of performance. And it's just important for us to have a good metric to see, okay, are we heading in the right direction? Are there no regressions, etc., in terms of performance? So that's why I think Criterion is a very important crate to add to anyone's attention.
It's very popular. Okay, well, final call to action. Anybody who's interested in MUN should check out their website, and all of the stuff I'll leave in the show notes. If you're interested in entering their Make It or Break It competition, that sounds pretty fun. Other things you could do would be check out some of the open pull requests and that sort of thing. There's a few good issues even for beginners in there, which I might even check out, and I encourage you to do the same. Big thank you to Bas.
Yeah, it was fun.
Big thank you to Remco.
Thank you to you too.
Thank you, everyone, and we'll see you in the next episode.